Okay. Hello to all my fellow work in progress people. Welcome to Runtime Cognition. This is Runtime Log 2. Today, I'll be preparing for on backend concepts. The goal is to just strengthen my backend fundamentals and understand how all pieces fit together, say from architecture to REST APIs, authentication, etc. Okay, let's get started. Okay, why does backend architecture exist? Let's start with a simple question. Okay. Okay, so we have a beautiful React application. Of course, it will have login page, dashboard, profile pages, note and many pages, and a progress tracker. Okay. Once user clicks the login, where should we store the user's details like email, password, completed logs, watch history, progress notes? Can React permanently store all of this? No, it can't, right? React is responsible for building the UI, user interface. I mean, like which the client will see. It is not responsible for permanently storing the data or making the business decisions. Okay, that's exactly why backend exists. So, backend architecture. Before defining that, two important terms. One is client and then other one is server. Yes, what is client? A client is any application that requests information. For example, it might be a React application, it might be a mobile phone or an app, it might be a browser, it can be a smart TV app. Okay, so client is the one which asks every time. Okay, so server is a program that receives requests and processes the request and sends the response back. Okay, so a server answers the client questions, like client asks, server answers. Okay, good interview sentence is the client initiates the communication while the server processes the request and returns the appropriate response. Great, I got it. Okay. Now we can define okay, backend architecture is structure and organization of server-side components that receives client requests, executes the business logic, communicate with the databases, and return the responses. Okay, there are four responsibilities for server. I mean, like for the backend. It receives the requests from the clients and it executes the business logic, whatever needs to be done, and it accesses the databases and then a response back to the client. Everything we said once it fits into these four categories. Okay, yeah, this is whiteboard time. So client can be a browser, React app. Okay, I'm gonna copy paste this to my whiteboard. I think I have already something. That's okay. This looks odd, but okay. So there's a client. Client can be either browser or React app or anything. So client asks the question, meaning it sends the request. So backend is where the business logics gets executed, the validation, authentication or authorization, everything happens. And the backend server communicates with the database through the queries, and then and backend responds back to the client. Okay. How does this actually work? Let's walk through a real example. Suppose user clicks on login. What happens? Yeah. So the client React application sends a request. It says, please log this user in. Notice something happened. The client is asking. It is not deciding. Yeah, it's just asking that please log in this user. The backend receives the request. Now the backend starts thinking questions like, does this user already exist? Is the password correct? Is the account active? Is the request valid? And etc. So these decisions are business logic. Okay, so what is business logic? Matlab? Okay, all this stuff. So business logic means the rules that determine how an application behaves. Okay. Hmm. Can a user log in? Can a admin delete a course? Can a customer place an order? Is an email already registered? So all these are business rules, application rules, and not UI rules. Okay. If needed, backend talks to the database. For example, find the user with this email. Okay, because that email or user information will be stored in the database. Backend does that communication with the database. Database simply stores and retrieves the data. Okay, database job is only to store and retrieve the data. It doesn't decide whether someone should be allowed to log in or not. Okay, it's not the work or job of the database. So then who decides? The backend receives the database result, it applies the business rules, then it prepares a response. Okay, so the decision maker is backend, not UI, not database. So login is successful, whether the password is valid or not, user found or not, account related stuff. The response is sent back to the client. Finally, React updates the UI. Maybe it navigates to the dashboard, shows an error message, displays the user or whatever, but React only displays the result. Backend makes the decision. Yeah, got it. So if we want a real world analogy, for example, okay, restaurant is there. So client acts like the customer who asks, okay, waiter, request response communication. Okay. So kitchen is the backend who decides, Chef is business logic. Storage room is database and preparing food itself and giving it to the client as response. The customer never walks into the storage room, yeah, to grab the ingredients. Similarly, the front end should never directly access the database. Okay. So there is no connection between the front end and database directly. Okay. So the backend acts as the trusted middle layer. Got it. So production example. Okay, let's imagine runtime cognition has a feature. Mark runtime logs as completed. Okay, so when the button is clicked, the backend might verify the user whether he is logged in or not, check the log number whether if it exists, update the user's progress in the database, recalculate the completion percentage, and return the updated progress. So all the stuff is happening in the backend. The front end simply displays updated information which is returned as a response from the backend. Got it. Okay. What is backend architecture? So it's nothing but is the organization of server-side components responsible for receiving client requests, applying the business logic, communicating with the databases, and sending responses back to the client. So it separates responsibilities to improve maintainability, security, and scalability. Got it. So mistakes might be thinking backend is only a data. No, thinking Node.js itself is the backend. Okay, no, there are many layers. Thinking React should connect directly to the database. No, I got it. So UI meaning front end directly will not communicate with the database. There's middle layer, like so many layers which we'll see. Thinking database decides business rules. No, database is only used for storage. Confusing data storage with business logic. No, I understood the concept. So yeah, first review notes. We are ready with that. Backend architecture. So React builds the user interfaces. Data needs to be stored permanently. Applications need rules and validation. The backend solves these problems. Yeah. Okay. So key components. So there will be client, front end, server, backend, business logic, database, request, response. So there's a flow. So client makes the request to the backend. So backend performs a lot of things based on the business logic, I mean the rules of the application, and it communicates with the database. And post that, it will send backend will send back the response to the client. Login flow. Client backend, database backend, and client intelligence side. The backend's four core responsibilities. Yeah, receiving the requests, executing the business logic, accessing the data, and return responses. Okay, okay. So first review notes is here. I'll just copy paste this. Okay. So this is asking me a question. How does the client actually send a request to the backend? Okay, that is an HTTP part, right? Hey, I understood the concept, like how you made me realize, understand the backend architecture, and you gave me just what is this? First revision notes. What about quick recap and flash notes? And then we'll move to this part. Okay, I understood this part. So whenever, so the client maybe any React application or a browser or a mobile application or anything. So the job of the client is to send the requests to the backend based on the user interactions. So what does the backend do? It has four responsibilities. So the first one is of course receiving the requests and based on the business logic, performing like whatever is needed, and then it communicates with the database to access the data, and it sends back the response to the client. Okay, that's all right. I got the concept. Once finish a topic. Yes, yes, yes. So quick recap, 2 minute revision. The flow. Yes, client asks the questions. Backend is the one who thinks and decides, and database provides the data. Backend decides. Client displays correct. Okay, I'll put this. Sorry. Mm, okay, and now we need to flash record. Also, I want the notes. Client sends a request to the backend. The backend applies the business logic, communicates with the database if needed, and returns a response to the client. It separates the front end from the database, improving security, maintainability, and scalability. Yes. So in the flash recall, this goes. Let it be. And what is the one more thing that you gave me? Runtime reflection. Yeah, I want this part as well. Can I paste it in the whiteboard? Oh my god, what's this? No, we'll put it in here only. Backend exists because frontend is responsible for the UI. Of course, it is not the permanent data storage for or for application rules. Permanent data storage in the sense like whenever user enters some email password or some information, this is not gonna be stored in the browser forever. It's not a permanent place. Application rules is like mm, how it should perform, like what are the features, what does it do, things like that. So a client initiates the communication, yes, by sending a request, while a server processes that request and returns the responses. Backend architecture organizes how requests are handled, business logic is applied, data is accessed, and responses are sent back to the client. So business logic represents the application's rules, not the UIs. Got it. The database stores and retrieves the data, but backend decides how and when the data should be used. Okay, this will not decide, only the backend will decide. Got it. The decision maker is backend, and frontend should communicate with the backend, not directly with the database for security purposes. The complete request response flow forms the foundation for everything we studied. Got it, bro. This is not needed, but yeah. Yeah, let's do that. Runtime reflection should be at the end of the entire stream. Yeah. Okay, I like the flow, but I'll record it. Hey, I'm loving this flow and I'm also understanding clearly what you're teaching me. Now I just got a small doubt, I mean small question. You're saying that front end is not supposed to directly talk to or communicate to the database, right? I understood, but tell me why with some examples. And post that will move to post that will move to next topic, HTTP. Yeah, why shouldn't the front end directly communicate with the database? Okay. React needs user data. The database has the user data. Why not let React fetch it directly, right? Yeah. Why? Problems are first one is security. Imagine a runtime cognition app has a users table. Okay, user table. It has some information like user ID, username, password, email, role, etc. React connects directly to the database. What stops someone from writing their own query? Yeah, they can do some queries like selecting the user or delete. Okay. If the front end had direct database access, anyone could inspect the network requests or modify the client code and try sending their own database operations. Okay, so they can directly communicate. The database cannot trust the client. That's why we place a backend in the middle. The backend decides, is this user authenticated? Are they allowed to perform this action? Is this request valid? Only then does the backend talk to the database. Got it. So without the backend, if communicates with the DB, anyone who controls the client can attempt to access the database. Now compare it with the proper architecture. React HTTP request and then backend checks for authentication, authorization, validation, database, etc. Then the backend acts like a security guard. So the business logic, okay. Oh, let's imagine Runtime Cognition has a rule. A user can only mark runtime log as completed if they have watched at least 80% of the session. Should React decide that? No, because someone could simply change the JavaScript in their browser. Yeah. Okay, so they could bypass the check. Instead, if React just sends that mark this lesson is completed to the backend, then the backend checks did the user actually watch 80%. If yes, then it updates the database and returns success. Yeah, this is a good way of doing it. The backend owns the application rules. If there are multiple clients, we have React website. Tomorrow we build app, iOS, hopefully. So should each application implement the same business rules? No. That would mean maintaining the same logic in multiple places. Instead, React app, Android app, iOS app, backend database. So now every client asks the backend, and the backend applies one consistent set of rules. Oh, so let's say we have multiple clients. Like, okay, should each application implement the same business rules? Not necessary. That would mean maintaining the same logic in multiple places. Okay. So everybody individually asks the questions to backend, meaning they make the requests. Backend, depending on its rules, it will respond. Communicate with the DB and response back. Database independence. Suppose today we use some PostgreSQL. Next year we migrate to the another DB. If React talks directly to the PostgreSQL, we need to update every client. Hmm. So React backend Postgres, later React backend, another database. Front end doesn't care which database is behind the backend. Yeah. So the dependency will be gone. The backend hides those implementation details. Okay, let's understand with a restaurant example. Okay, do you walk into the kitchen and start opening the refrigerators? No, I don't have access, right? You tell the waiter what you want. The waiter communicates to the kitchen. Kitchen prepares the food. The waiter brings it back. Customer, waiter, kitchen, then the storage room, they get it to the kitchen, then the waiter, then it comes to me. Yeah. The waiter is the no, that is okay. Waiter goes to the back end. The storage room is the database. Customer never directly accesses the storage room. Understood. Why shouldn't the front end communicate directly with the database? The front end should not communicate directly with the database because it would expose sensitive data and credentials like password, email, bypass business logic, and make security much harder to enforce. The backend acts like a trusted middle layer that validates the request is coming from the client and applies the business rules and controls the database access and returns only the data that client is allowed to see. Okay, the front end should never directly communicate with the apps. The kind of backend engineering interviews you are preparing for, that's the right mental model. If you go deeper into the backend development, you will learn there are some specialized architectures such as certain backend as a service platforms where the client can interact with the database through tightly controlled security layers and policies. Okay, exceptions with their own safeguards. First of all, let me understand the normal backend, then I'll go to backend as a service platforms. Okay. For now, stick to front end, back end, database. It will help you understand the rest like HTTP, REST APIs, Express, Authentication, JWT. Oh my god, okay. Yeah, wait. First, I'll put this one. This is a nice one. Okay, what are you saying? Now we have closed the biggest why behind the backend architectures. Yeah, why, what, and all I understood. So let's move on. Like, if the front end can't talk to the database directly, how does it communicate with the backend? That's the perfect transition into HTTP because HTTP is the language that the client and backend uses to talk to each other. Okay, okay, let's start with. Okay, so HTTP stands for Hypertext Transfer Protocol. Let me just check if the stream is going on. Okay. Okay, so HTTP stands for Hypertext Transfer Protocol. Before we define that, let's connect it what we just learned. Yeah, connecting the dots. So we know this much. Yeah, there's a client, say maybe React front end. So there's backend, there's database, and the front end doesn't communicate with the database directly, and it communicates directly to the backend. But how does it communicate is the question. So the front end shouldn't. Yeah, instead it communicates with the backend. How does the front end actually communicate with the backend? Yeah. Okay. Does React call a Java function? No. Does it access Node.js memory directly? Does it connect through database? Like how? No. So there is something HTTP. Why does HTTP exist? Imagine you are in India. Imagine what I am in India, yeah, and your friend is Japan. You both want to communicate, but there is a problem. I speak English, the other person speaks Japanese. Communication becomes difficult. Yeah. So to solve this, both agree to use a common language. Now communication becomes possible. Or a translator maybe. Computers have the same problem. Okay. Front end and back end are two separate applications. How do they agree to communicate? So they are using the HTTP, Hypertext Transfer Protocol is a language that they use to communicate. Okay. Uh, Hypertext. Originally, websites only contain text connected using hyperlinks. That's where hypertext came from. Oh, okay. Just text. Okay. Now today what all it transforms HTML, CSS, JS, JSON, images, videos, PDFs, audio. So don't let the names confuse you. Okay, got it, yeah. Uh, Transfer means moving the data from one place to another. Protocol is the important word, new terminology. Yeah, a set of rules that two systems agree to follow while communicating. Okay, so that's why it is hypertext transfer protocol. Okay, traffic rules. Yeah, everyone agrees. Drives on one side, stop at red signal, and go on green. Yeah. So without rules, there will be chaos, of course. So similarly, HTTP defines the rules for communication between a client and a server. Okay. So definition is like it's a communication protocol that defines how a client and server exchange the requests and responses over the web. Okay. Notice the keywords communication, protocol, I understood, client server, I understood, request and response. Let's go deep in that. Yeah, whiteboard time. I think I better make one more notion for whiteboard because, yeah, I better do that. This whiteboard damn thing is not working properly. How do I add it? Whiteboard. I mean, like flow diagram. I would better say that. Flow chart, flow diagram, whatever. For the topic backend architecture. So I had one. Where did I have that? Hmm. This one first. Flow diagram. Yeah. And then the next one comes like this one. Okay. Shit. What's the question? Okay, how does frontend actually communicate with the backend? So they both communicate using HTTP requests. So HTTP is not stands for Hypertext Transfer Protocol. So it's nothing but a communication language that both client and the server agreed to communicate. So then the backend server processes the requests and sends back the HTTP response to the browser, and the frontend updates the UI. I understood. Whiteboard time. Yeah, pause here and explain the diagram. I understood. I explained. How does the HTTP work? Okay. Now, until now, I understood how does the front end communicates with the back end and why it doesn't communicate with the database directly. Now, how does the HTTP work itself? Okay. Suppose user opens a dashboard. React says, I need the user's dashboard data. It sends an HTTP request. Say get request to dashboard. Don't worry about get yet. Yeah, we will learn in the next topic. For now, just think of it as please give me the dashboard data. Okay. The backend receives the request, it processes that. Maybe it asks the database for the user's progress because, okay. Then the backend prepares a response, okay, in a JSON format. Okay, keyword value, name, developer, completed logs, current streak, etc. So this data is usually sent in a format called JSON, yeah, JavaScript object notation. For now, think of it as a structured way of representing data. Okay. So React receives the response, it updates the UI. The dashboard now displays the whatever the needed, like the log number and the streak. So request versus response, yes. So these two words will appear throughout the backend development. So a request is a message sent from the client to the server. So it's asking questions, right? Asking it to perform an action or provide information. So request is like a question. Okay, please log me in, get my profile, show my dashboard, create something, etc. So the client always initiates the conversation. Okay, the response is the server's reply. It's the answer after processing the request. So like login successful, password is valid or not, the profile, okay, success, failure, etc. So request response. So request is nothing but the client is questioning, and response is the server's way of replying question and answer. Okay. Real world analogy. Okay, I'll order food online. You place an order, restaurant receives it, the chef prepares it, the delivery partner brings it back to the customer. Customer, so customer orders it, places the order, restaurant, food, customer got it. The order is the request. The delivered food itself is the response. I understood question and answer type. HTTP follows the same pattern. Production example is when we open the YouTube, the browser sends the HTTP request asking for your home feed. Oh, okay, okay. When I click the YouTube, the feed will always be there, customized to the user, right? So immediately an HTTP request is sent. Okay, the backend identifies who am I, fetches the recommended videos according to my settings, and then it returns the data. The front end simply renders those videos on the screen. Okay. If an interviewer asks what is HTTP, so it stands for, yeah, Hypertext Transfer Protocol, and it's a communication protocol that defines how the clients and server exchanges the requests and responses over the web. The client sends an HTTP request, the server processes it and returns an HTTP response. What might be the common mistakes? It's not a programming language, it's not the backend, it doesn't store the data, yeah, it doesn't process business logic. It's simply the communication protocol, yeah. This is between the client and server. Got it. So first review notes. We are ready for first review notes. HTTP. So why the front end and back end are separate applications? They need a common protocol to communicate. So HTTP provides standardized way to exchange the information. So the terms here are the protocol, HTTP request and response. The flow will be like client sends the HTTP request, backend receives and sends back the HTTP response to the client. HTTP doesn't decide what happens. Yeah, it doesn't. Backend is the decision maker, right? We learned that. It only defines how communication happens. Think of HTTP as a language or a set of rules, while backend is one of the making decision. Yeah, got it. We'll pause as before. Quick flash. Okay, first I'll put this in my first revision notes. Where am I? Flow diagram, right? First review notes. Okay. So you're asking me something? Next thing you will naturally ask is if HTTP is just a communication protocol, what exactly is inside HTTP request and an HTTP response? Yeah. So that's the perfect bridge to next part of HTTP. We'll first understand the structure of a request and response. Yes, please. And then we will generate the quick recap. Yeah. Okay. Sure. Let's do that. Okay, what's actually inside an HTTP request and response? Okay, up until now we have been saying client sends the request, server sends a response back. Okay, but what exactly is a request? Is it some random message? No, HTTP defines a proper structure, just like a letter has to from subject, body, date, etc. And HTTP request also has a fixed structure, byte port time. Okay, HTTP request has HTTP method. URL or endpoint, headers, and body optional. Don't worry if these terms look new. No, they are not new, but I'm not 100% sure of the answers. That's why I'm learning. It's okay, I'm learning. Oh, 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 oh. The question I need to copy else. What is the point of the sizing and all? We'll do it later. Let's not waste time. Okay, so what does HTTP request contains? So the HTTP method and an URL endpoint, headers, and the body. And body is optional. Okay. So what is HTTP method? The first one. So what is it? Yeah, it tells the server what action the client wants to perform. Think of it as like a verb in English. Okay, CRUD operations. Create, read, update, delete. HTTP has verbs too. Examples: get, post, put, patch, delete. Okay, so these are the HTTP methods. We'll study each one in the next topic. For now, just remember HTTP method equals to what action do you want? Yeah. URL or endpoint. Imagine you call a restaurant. The first thing you tell them is, I want a pizza. Yes, give me the food. No. Okay. You specify what do I want. Yeah, there will be a menu, right? Yeah. Similarly, the URL tells the backend which resources you are asking for. Okay. HTTP method like get and URL is like what I'm asking for. Okay, user or courses or login, what information exactly. Okay, get and post it. Okay, focus on slash user slash nodes. Okay. These tell the backend where to go. Okay, new terminology, endpoint or root. Okay, an endpoint is simply a specific URL on the backend that performs a particular task. Okay, for example, it's specific URL. Okay, it's like a root path slash login slash profile slash dashboard slash runtime logs, etc. So headers, this one confuses the beginners. Think of headers as extra information about the request. Okay, not the main data, just information about the request. Okay, examples: language preference, content type, authentication token. I imagine sending a courier, the package has inside, okay, a laptop, but outside label it has the receivers, priority, fragile, etc. Right? Okay, so headers are like outside label. Oh, okay. So the body is the package. Mm. The body contains the actual data we want to send. Suppose we are logging in, then we will send like email and password, right, of the user. So the body is the actual data. Header is just information about what is that? A request itself. It's okay. This is better analogy. It's like a label on a parcel. But what inside the parcel is body. Okay. The body is optional. If we are simply asking show my profile, we don't need to send any data. Yeah. So many requests have no body at all. Okay. Okay. Putting it all together, yeah. Okay. The request could look like HTTP method, say post URL. URL is slash login. Headers is content type application JSON. Body is optional, or since it is a login, we need it email password. So the entire package is called HTTP request. Okay. So HTTP method is there. Which method? Post method. So where we are about what information like slash login root endpoint and headers as application JSON. This I want to know. So the body we are sending because it's an login request, email and password. Yeah, front end React post slash login endpoint headers and body backend checks the email and password database. Okay, this is about the HTTP request. So the whiteboard time. Where are you, whiteboard? Whiteboard in the sense flow diagram. Open it, yeah. Quick, quick, quick. Something. Okay, now go to the response. Okay, it also sends in the structured format. So HTTP response has status codes, it has headers, it has body. Okay, it also has the headers and body. So body is the actual data, headers is just the label or the information about the request or response itself. So it has status codes. Okay. We will spend much more time on status codes when we build APIs. Okay. For today, the backend doesn't reply with a random message. It follows HTTP response format. Okay, mental model. Think of HTTP like sending a parcel. You package courier rules receiver. Yeah. The courier company defines how packages should be packed and delivered. Exactly. Okay. HTTP defines how clients and servers exchange the information. It doesn't care what the data is. Okay. Yeah. If it only defines the communication format. Hmm. An HTTP request consists of a method, okay, an URL, headers, and optional body. The server processes the request and returns a HTTP response containing a status code, headers, and optional body. So headers and optional body are there in both. Status code is there from in the response, and method and URL is there in the request. Okay. First review complete. Okay, I need to paste it. Why HTTP? In the sense, front end and back end are separate applications. They need a standard way to communicate. So HTTP provides that standard. So there are terms here: protocol, request, response, method, endpoint or root, headers, and body. Yeah. So HTTP request structure is like there's a method, there's an URL, there is headers and body, which is optional. HTTP response has also headers and body and status code. Okay, HTTP defines how communication happens, not what business logic should execute. Okay. Comes to the quick recap. Communication flow like client HTTP request, backend HTTP response to the client. HTTP request ka structure. It has method URL and this and response. Okay. The keywords, online summary. The flash recall. I'll put this also just in case not needed, but yeah. Now that you know how the front end communicates with the back end using the HTTP, the next question is what? But why do we have get, post, put, patch, and delete? Why isn't one request type enough? That's exactly where REST APIs begin, and it's going to connect beautifully with everything you have learned so far. Okay, it's time for REST APIs. Okay, let's go. Stream length. But I need to learn REST APIs also now. What was the topic? Okay, I'll complete REST APIs and let's see. Yeah, third topic, REST APIs. Why do REST APIs exist? Let's imagine there were no rules for designing APIs. Let me drink some water. Okay, why do REST APIs even exist? Let's imagine if there were no rules for designing APIs. Suppose building runtime cognition backend. For fetching all the users, you decide slash get all users. Another developer creates slash fetch users. Another creates, okay, show every user. Okay, if multiple persons are working on the same, someone else creates, okay, all of them work. But imagine joining a new company. Every project has completely different API naming. Every backend behaves differently. Every endpoint follows the different rules. So it becomes difficult to understand and maintain the applications. So we need a common style for designing the APIs. So that style is called REST. Okay. So first it stands for representational state transfer. Okay, don't worry about memorizing the full form. I know that. But I want to understand why, what, how, the deeper concept. Full form though I know. Even experienced developers rarely say the full form in day-to-day work. Yeah, what's the important understanding is that idea how it works. So REST is it stands for representational state transfer, which is an architectural style that provides a set of guidelines for designing the APIs in a consistent, predictable, and scalable way, which helps maintaining the applications. Okay, notice something important. What guidelines? Yeah, set of guidelines, not rules. Why? Yeah, why? Because REST isn't a protocol like HTTP. HTTP says this is how communication happens. REST says this is a good way to design your okay APIs. It's not the mandatory rules, but it's the guidelines. Okay, understood. So HTTP versus REST. This is one of the most common interview questions. Okay. Communication, how to talk. HTTP uses HTTP to communicate. REST organizes APIs consistently. P is the language, rest is the grammar. Oh wow, this is a great analogy. You can technically speak a language without proper grammar. People may still understand you, but communication becomes messy. Rest brings the structure. Okay. Imagine roads. HTTP defines traffic rules. Stop at red, drive on the left, wear a helmet. Yeah. So these are the communication rules. But rest is a city planner. They decide where the roads should go. The junctions are named. Okay. Organizing is about communicating. Okay, I understood that example only. HTTP is like a language and REST is like a grammar. Okay, how does REST works? Let's build runtime cognition. Suppose we have runtime logs. Okay, first I will put this whiteboard. Oh, where was I? Okay, how does the rest work? Let's build runtime cognition. Suppose we have runtime logs. Without rest, someone creates get logs, create new runtime, yeah, a lot of things. Another developer writes, okay, as they wish. Everything works, but every project looks different. REST says, let's organize this. Instead of inventing new names, use resources. New terminology, resource. Yeah, a resource is simply the thing your API manages. Okay, examples. It manages users, courses, products, orders, runtime logs, nodes. These are nouns, not verbs. Okay, so these are all resources. Okay. If our resource is runtime logs, REST says keep the endpoint simple runtime logs. Now, instead of changing the URL, change the HTTP method. Okay, so resources runtime logs. Get all the runtime logs. Post means create the runtime log. Put means replace the runtime log. Okay, patch means update part of the runtime log. Delete means delete that particular runtime log. Oh, this is one of the most important whiteboard diagrams. Backend development, don't rush it. Okay, okay. I'll put it first and then imagine you have never worked out before. You see get slash user without opening the code. You already, oh, this fetches the users. Yeah, that's the power of conventions. Okay, REST makes APIs predictable. Production example, think about an e-commerce app where the resource is products. So using REST we do get products, so get all the products, post products, create does the creation of the new product. So patch means it updates the product number 15. Delete means it does deletes the product number 15. The URL says focused on the resources. Okay, the HTTP method tells you what action to perform. Okay, REST is an architectural style for designing the web APIs. It uses HTTP methods and recommends organizing the APIs around resources, while HTTP methods like get, post, put, patch, and delete indicate the operation to perform. REST makes APIs predictable, maintainable, and scalable. Okay, REST and HTTP are the same thing. No, I understood. HTTP is the communication language, matlab protocol, and REST is like grammar, so it's the set of guidelines to design the API in a good way. REST is not a programming language. Yes, REST replaces no. Every API on the internet is perfectly RESTful. No, REST uses HTTP. REST is a design style. HTTP is the communication protocol. Understood. Okay, let's get to the first review notes. Different API designs become inconsistent. REST provides a common way to organize the APIs. Okay, so new terms was REST API resources endpoints. Key insight, HTTP is equals to communication, REST is equals to API design. I'll also put one analogy here. It's like a language. This is like a grammar. Okay, grammar spelling correct. It's okay, whatever it is. Okay, resource examples, runtime logs. I'll not understand if I see this after an year. So let this be uh, products slash users, something like that. Then I'll understand. Different action happens by changing the HTTP method, not by inventing the new endpoint names. Yeah, I understood that. So for the same resource, we can put get, put, post, something like that. Okay, that whiteboard diagram I can paste it here now, or this itself. Production example. Okay, okay. I want to stop here before the recap because there's one question I expect you will ask naturally. Okay, what is that? What exactly is an API? We have been saying REST API, but we never actually defined API. Okay, application programming interface, correct? And you are absolutely right if you ask that we shouldn't move on until we define API first and principles. Once we understand that, the rest of rest will make more sense. Okay. Okay. Let's do that. So API means application programming interface, API endpoint. Okay, you take it over from there. Yeah, get stuck. Application programming interface. What is an API? What is it? Yeah, intuition instead. What is an API? Imagine front end wants to log a user in, can React directly call your backend function? Login user, email, password. No, why? Because React and the backend are different applications. They don't live in the same process. They communicate over a network. So the backend needs to expose an entry point that says, if you want to log in, send your request here. Okay. So the entry point is called an API. Okay. Whiteboard time. Hmm. So React app is there. I want to log in. Where it will go in the backend. So API is like entry point, login endpoint. You come to here so that the backend will take over and all things happen. Okay, think of an API as a reception desk. Imagine you are entering a company. Do you walk directly into the CS office? He will not allow if I want to walk. You first go to the reception desk. You say, I would like to meet HR. The receptionist knows where to send you. So similarly, the front end doesn't directly talk to the business logic. It goes through an API. Okay, front end API, back end database. The API is like the reception desk and are the front door of your backend. So what is an API endpoint? Suppose your backend offers these features: login, register, get profile, update profile. Each feature needs its own entry point. So those entry points are called API endpoints. So post login, post register, get the profile details, patch the profile, etc. So each one is an endpoint because its specific place the client can reach the so to perform one task. A simple mental model. Hmm, is a shopping mall. Backend has login shop, profile shop, note shop. Okay, the API is the mall itself. It exposes services to the outside world. The endpoints are the individual shop entrances. Okay. So API is the mall itself, which has all these shops. Like it will advertise all this. The endpoints are like the shop entrances. You don't enter the mall through the wall, you enter through a defined entrance. Yeah, exactly. Likewise, the front end don't jump into the back end code. It reaches the back end through defined API endpoints, putting everything together. Okay, client makes HTTP request to the backend. Backend in the sense first some endpoint, right? Entry API endpoint login, then the backend logic database HTTP response. React updates the UI. Notice how every concept connects. Yeah. Backend architecture, we need a backend HTTP. We need a communication protocol. We need defined entry points into the backend. Endpoint a specific URL that performs one task. So REST is a convention for designing those endpoints consistently. Nothing is isolated. Understood. If an interviewer asks what is an API, so other than what it stands for, it's a contract or interface that allows different software applications to communicate. In web development, an API exposes endpoints that clients use over HTTP to request data or perform actions on a backend. And if they ask what's an API endpoint, a specific URL exposed by the backend that performs a particular operation such as logging in a user or fetching profile information. No, it's like I'm not an absolute beginner. I do know the terms and all, but for deeper understanding, I'm doing these sessions for myself. So, did you give me the first notes? Whiteboard thing. I wanted this point. Fine. Hey, you know, right? I know the terminology here. I'm doing this study session so that I can go deeper and clearly take time to understand like what does it mean. But the terminology is I know it. Okay, now let's give me that first review notes. Yeah, half and half. I know how it works also, but I want to go deeper. Okay, REST APIs notes. Let's copy. Didn't I do the REST API notes? Did I do? HTTP REST APIs. Oh shit, I did it. What is there here? Okay, I have the first notes. No need to copy it again. But this looks good, so I'll put it there. What is there? Whiteboard summary. Okay, shopping mall. The mall represents your backend. The each shop entrance is an API endpoint. You enter through a specific shop depending on what you want. Yeah, you don't break through the wall to reach the shop. I understood. This is what is okay. I'll put it in deep notes. Production example. Runtime has a resource called runtime log. Instead of creating different endpoints, get logs, create log, update log, delete log, will do the naming according to the resource. Yeah, I remember. So runtime logs. Then change the HTTP method depending on the action. Key takeaways. REST is an architectural style, not a protocol. HTTP defines communication. REST organizes the APIs in a predictable way. An API is just an interface through which applications communicate. An API endpoint is a specific URL that performs one task. REST encourages organizing the APIs around resources rather than actions. Hmm. First, I'll put this one. Real world analogy. I like this one. So let it be in. Okay, production example. I don't want that. What is REST? REST is an architectural style. Okay, it recommends organizing the APIs around the resources. Different HTTP methods are these, and they are used to perform different operations on those resources, making the APIs consistent, predictable, and scalable. Yeah, okay. This I'll put it in flow diagram. This is even more better. Or I can put it as a first, no, after the backend. We'll go one at a time. I need one separation here. The flow till now. Okay. Okay, where are we? Backend architecture done, HTTP done, and how REST APIs organizes them. HTTP methods next, request response lifecycle, and then Node Express. Okay, Node is something we are not actually leaving HTTP yet. Yeah, is one topic. REST is another topic. Get post is another, but they are all connected. Yeah. Use of protocol. REST is like design style. Now, okay, fourth topic HTTP methods. But you didn't give me the what year you moved on. Hey, before we move to the next topic, HTTP methods, for REST API, you just give me that, you just gave me the first review notes. You didn't give me quick recall and flash recall ka notes. Quick recap and flash recall ka notes, yeah. We'll put it there and then we'll move to HTTP methods. Yeah, I want the notes. Quick recap. I understood, but I just want to put it there. Backend API endpoints, resource based design, keywords, one line summary. Quick recap. Flash recall. Okay. Okay, completed topics, backend architecture, HTTP, REST APIs. First review, yeah. Okay. Okay, let's go. AP methods. The URL changes sometimes. Yeah, yes, here. The method changes too. But why do we need both? Why can't we simply write login profile delete note? Let's find out, okay? So why do HTTP methods exist? Imagine there's an endpoint slash users. React sends a request and the backend receives slash users question. What exactly do you want me to do with that users, right? So should I show all the users, create user, delete? What should backend do? So the backend has no idea. The URL only tells where, but it doesn't tell what to do with that. So that's why HTTP methods exist. Mental model is like, think of like a Google map. When address tells where to go, it doesn't tell what to do once you get there. Similarly, slash users tells the resources, but HTTP method tells the action. Okay, HTTP method, and HTTP method tells the server what action the client wants to perform on that particular resource. So there's URL where it should go. HTTP method what to go after going there. So when we combine them, we get, okay, go to slash users and get the users. Now the server understands, go to users and fetch the users data. Okay, resources slash users get read data, post, delete. This I know. Pause here and explain the diagram in your own words, since I know I'm not putting it there. The biggest takeaway, the resources stays the same. The method changes the action. Yeah, resource is slash users only. But the method get, post, delete, HTTP methods we are changing based on what action we need. Like based on the CRUD operations. So the five HTTP methods you will use the most. So get is the first one, like to retrieve the data, meaning to read the data. Give me the information like get slash users. Backend response will be like, okay, in a JSON format, okay, the name and the ID, nothing changes in the database. We are only reading it, yeah. So real example, when we open say YouTube, the home page loads. So you are simply requesting the videos. So that's a get request, okay. Post purpose of it is creating new data. Post slash users. So back body will be like, okay, name runtime cognition. So the backend creates a new user in the database. Okay, and database also updates it. Creating an account, uploading a photo, adding a note, creating runtime logs. So all anything we are writing or creating is post. Only fetching, reading data is get. Okay. Now put one. Replace the entire resource. Okay. So there's runtime cognition name, role, city. Put sends name RC, role is developer, city answer. Okay, everything gets replaced. So patch is smaller. Suppose only the city changes. Acha, okay. City Mysore. Everything else remains unchanged. Only the specified fields are updated in the patch. A small patch. Okay. Put means entire replacement. Put replaces everything. Patch updates only changed fields. A common error question is put replaces the old resources while patch updates only the fields that gets changed. Delete. So remove data. Delete slash user slash 5 meaning you delete the user with the ID 5. Okay. Production example, let's design runtime cognition backend. So let's say resources is runtime logs, operations get operation. So to fetch all the logs, post operation. So it will create a new runtime log. So patch means okay, update not entirely but only that part, some particular part. Small patch, update runtime logs. Yeah, delete is remove it completely. Nothing. Notice what the endpoint hardly changes. Yeah, method tells the backend the intention what to do. Why not create endpoints like get users, delete users? In RESTful APIs, the endpoint represents the resource and the HTTP method represents the action. This keeps APIs consistent, predictable, and easier to maintain. Okay, that's the reason we don't use get users, delete. Instead of that, we just use uh, get method slash users, something like that. Delete method slash user, understood. Resources will stay constant. Depending on the action, HTTP method will change so that the design style of the APIs will be consistent, understood. Thinking get can create data, no, it will only read. Post for every request, okay. Confusing put and patch. Put is like entire replacement, patch is like small update. Putting the action in URL instead of using the appropriate HTTP method. Okay, instead of this one, delete HTTP method slash user would be the right one. First review notes. Yes, please. I'll put it first. Why HTTP methods means the URL tells the server where, but HTTP method is the one which tells server what action to perform. I understood this thing. Key resources where method is what. Okay, understood. Same resource but different actions. According to runtime cognition. Yes, that's all. Yes, let's go. Okay, I understood. Resource means where, meaning like users are, products are, profile are, void. Methods, I understood. So the complete flow is like client makes get a request and backend understands what to do, means we need to what action to perform and where. So the business logic runs and database communication happens, response comes back to the client. So the CRUD mapping, so create means post, read means get, update entire means put, only partial means patch, delete means remove it. Post, get, put, patch, delete, understood. So put versus patch, I understood this old replace everything or update only the small changed fields. Runtime cognition example, I understood. Keywords, I understood. The endpoint identifies the resource. So while the HTTP method tells backend what action, I understood. Flash recall, HTTP methods, memory triggers. This quick interview, Idella, this I know. I want to copy only this part because I know this topic. Come on, flash recall, where are you? Memory triggers is not needed. This is not right. Okay, so in this runtime log 2 today, what and all I understood backend architecture. So the backend is the secure middle layer between the client front end and the database. So there is no direct connection between the front end and the database. It receives requests, backend receives the requests, applies the business logic, interact with the database and returns the responses back to the client. The front end should not communicate directly to the with the database because of the security and business logic maintainability. Okay, and then next topic was HTTP. So it is a communication protocol used by clients and servers. So communication happens through a request response cycle. An HTTP request contains a method, URL, headers, and an optional body. HTTP response contains the headers, optional body, and status code. So REST APIs. So this is an architectural design style and not a protocol. HTTP defines how systems communicate, while REST defines how APIs should be designed. Okay, I just loved that analogy. HTTP is like a communication language, but REST gives the grammar more structure for designing the APIs. So APIs expose functionality, endpoints, or specific URLs for individual operations. Okay. REST encourages organizing APIs around the resources instead of actions. Yeah, same resource, but the actions keep changing. HTTP methods. So the URL identifies where the request should go. Yes. I mean, like where, which resource, either login or product page or users page or where. So the HTTP method tells backend what to do, which action should it perform. So the CRUD operations map naturally to HTTP methods. So create means post, read means get, update means put or patch, and delete means delete. So if it is full update, complete replacement, go for put. If there's a small update, means only updating the changed fields, then we use patch. So put replaces an entire resource while patch updates the changed fields. Okay. So complete mental model of runtime log 2 today's. Okay. So when user makes a perform some action in the UI, React browser client. So client makes the HTTP request. So how it makes means through HTTP protocol is used by client and server to communicate. So there comes the REST API endpoint. It goes to backend server. So then backend decides based on the HTTP method and the URL endpoint where to go and what to do. So the business logic happens. Authentication we haven't still gone there. Then the database communication HTTP response comes back to the UI and the React updates the UI. Yes, today's topics covered backend architecture done, HTTP, REST APIs, HTTP methods done. Yeah, I have all the notes also. First review, quick recap, flash recall, runtime reflection, whiteboard diagrams. Yeah. Okay, I want this runtime reflection also. I'll put it at the end. Okay, I'll copy paste it here or I'll create a new page. Okay, I'll do it late. Okay, done for the day today. Okay, I'm just learning. We'll see you in runtime log 3. Thank you.